So today is very important for me because this is the first talk after COVID that I'm giving in person. So since 2019, I've been only online, and I hope you have a good time today. So also, I haven't been traveling as much. So yesterday, I picked up my briefcase, went to the airport, landed in SF, went to the coffee shop, wanted to buy coffee, and my bank texted me, "Hey, what's up? Someone is trying to steal your money from your credit card." And I'm like, "What?" And they're like, "That doesn't look like you." And I'm like, "No, it's me, really." So the bank could do that because they were using what we call real-time machine learning. They were able to act before the transactions that they saw was fraudulent went through. Well, I didn't buy goddamn coffee. Well, I did buy with a different bank. Probably they were not that real-time. And recently, we're seeing a lot more use cases for real-time machine learning. The classical one is with bank account. But others right now include recommendations on social media. So now the social media use a lot of AI stuff. It's natural language processing, computer vision, deep learning, reinforcement learning, everything just to keep you updating your feed, seeing, like putting likes, commenting and everything so that you are fully in that. And you might not see your friends as often on this feed. Because apparently capitalists don't have any interest to keep your friends up. They want only ads. But still, TikTok took that to the whole another level. So we knew recommendations before, but TikTok made it so that billion people would just update their feeds again and again. They posted good use cases about how they build it, and I encourage everyone to check that. So apart from that, any type of a website that has anything to sell wants to personalize that experience of the users that landed on their website in real time. So someone just opened your website and they just started to look. So your work is to spy on them, to understand what they're searching for, where they clicked, where they stared at, and recommend them. So listen, you have one shot, one opportunity to sell everything you ever wanted in one moment. Would you capture that or let the user slip?
Capture it.
Yeah. So I'm Oli. I'm responsible for DevRel at Bytewax. We have a booth 401. We serve coffee there, but that's not the only reason to come to us. We love streaming, data, and I personally love to chat about communities, so please welcome. Excuse me. So today we're going to discuss a few things. We're going to start with the real-time, latency and staleness. Then we will move to how the classic machine learning workflows look, and then discuss the online predictions, their challenges, and solutions that we have. So real-time. What's that? So I think of real-time as something that can be perceived by a human as being real-time. This is a bit of recurrent and fuzzy definition, but that's what that is. If you need a number, that's something that happens in sub-second realm. But in fact, that really depends on the context. Some things might seem like years ago, like, oh, real time, I got this in 5 minutes or whatever. Or you're okay to invest some time into something. And some things are not. But recently, we got in a time where we're very impatient. So Google shows that even 100 millisecond latency drops the search traffic significantly in terms of Google 0.2% is significantly. And other companies also show that any increase on any decrease on the loading time, any improvement gives you more conversion rates. So if you're, say, work at Walmart, and as a software engineer, you're able to speed it up by second, well, you're promoted. I don't know, you're a millionaire. This is really cool. At the same time, as a software engineer, you've heard a lot about the latency. But what you might not heard a lot about is staleness. So machine learning learns about patterns in your data. So you look at the data and now you know. But that raises a question. What if this pattern change? And they do over time. Oh, I just realized the GIF doesn't change. Oh no, this is spoiler. Yeah, so it goes down actually. This is GIF. So yeah, the model over time can decrease in the effectiveness of how they predict what is true. That happens, for example, when you think about fashion. This year, we all wear yellow. Next year, yellow again. No, sorry, that's not what's happening. It changes. So we need to update our model as well. That happens also with recommendations that are happening in real time. So people listen to Spotify. And here, before that slide, I was going to ask you if anyone remembers who Gautier is. I see one hand. So I was going to say, no, it's somebody that we used to know. Yeah, so there is a good case study by LinkedIn, where they were measuring their recommendation jobs. So LinkedIn posted employers post their jobs on LinkedIn. Those jobs can be available as a recommendations to someone who is looking for a job, and they simulated different delays on how soon after the job is posted it's going to be recommended. So they took the baseline of 1 minute. So if it happens immediately, then we don't see any decrease in how often people click apply job. But if it takes 24 hours, which seems to be not a big deal if you're looking for a job, but still, it has 4.45% decline, which is in the size of LinkedIn huge. So that brings us to a point where we think about the machine learning and about the real-time part of it. That's not only the latency, how fast the model responds, but also how fresh the data is. And when we consider where we want to go with our real-time machine learning, actually, we need to do this, ask important questions. So first, not all AI and ML products has to be super fresh. So if you were, for example, try to decide based on the photograph, if it's a cat or a dog, then your model will stay like that almost forever, just because the evolution made the dogs and the cats different. So it's not going to change in a year. It takes millions of years. This is the first thing. The second thing is that refreshing models can introduce unwanted feedback loop. And that happened actually with Bing search, with their images. One of the input features that they considered when they were running their algorithm was the number of clicks in the last X minutes. And because they were just recommending that, people were clicking on that. And they would consider that as a good picture and recommend that over and over and over again without updating that with new data. And it's expensive, of course. Maybe it's not that important for you that it should be fresh. So these are things that would make your machine learning real time. Like they happen right there, right here. We don't wait a lot, and it's fresh information. So let's take a look at the classic ML workflows, because we know this technology even before it went real time, right? We were doing that. So what we were doing is a data scientist would have their model. They would train and evaluate that offline, somewhere there, maybe in their Google Colab notebook, who knows. Then they would do the prediction offline in a batch job. And they would upload that somewhere in the prediction outputs in a fast storage like Redis or any key value fast database, doesn't matter. And then the app can grab that. The difference is, again, why TikTok is so popular and Netflix was behind. Because Netflix was doing that in recommendation in the batches. And they were not as fresh, as engaging for people. So if we were thinking about this, then, okay, it's super easy to implement, because most likely you can reuse the infrastructure that you use for training, tools and other things. So it scales very easily. You can run however many times you want. And it's known for years, so people would just run it, and you don't expect anything to fail. Because, again, you've done that before, you tested. And it's really fast, so it's low latency, because the answers are right there for you in the fast storage. Super cool. The cons are that, of course, it's stale. Then if the model had problems somewhere months ago, then when it was run, we might not know, because we don't have a quick feedback. And it doesn't scale for complex input types. In the universe of, if you need something really big, that would be really hard to put in the fast storage and retrieve. But, so what do we do? With low latency and high staleness. How can we do a small step forward? Maybe not necessarily redo everything, but a small step forward. So that brings us to this thing. I want to review this diagram again. So here I had my model as a whole thing, but now I want you to think about this as two services. There might be more of that. For the purposes of this presentation, we should think about features and prediction service. So now we still have our data warehouse, Snowflake S3, doesn't matter. It talks to the feature service, calculate the features in batches, same stuff, the prediction service, put them into the output. So now we want to talk about online prediction. So online prediction, same diagram, one more step. Real-time computation. So now we can compute some of the features based on the input that we have. So a user, a caller, this app, has a new input. Now we can calculate and reuse the train model we had before and do prediction in real time? Well, most of the systems probably would use the both things, so we still keep our batch work, but we do our best to guess the real-time prediction. Yeah, and of course, higher latency. Right there, we did real-time computation, and it, of course, added latency, but lower staleness, because, yeah, we do that in real time. So how what challenges? If it was that easy, everyone would just do that right there. But obviously, there are a lot to cover here in online prediction. It's a very big topic. And, but I assume that people here at current conference mostly are software engineers or people who are running teams with software engineers and data scientists. So I want to talk about the collaboration between teams, because now it is present when you have real-time machine learning. And then I want to talk a little bit, touch on the model level optimizations, because even if you are not data scientists, it's a good thing to understand what can be improved there. And then the serving level. So that's something that software engineers do. So imagine a data scientist at Instagram created a model where they're trying to calculate something, I don't know, something fashionable. So they train and evaluate the model online, they choose the pictures, everything is good. Now they hand it over to someone who's doing the online part, and they're like, okay, we'll just rewrite this features to online pipeline. What can go wrong? So, and in fact, tons of things go wrong. They're starting with something like, so we're at streaming conference here, and we know that the streaming data is unbounded, and like you don't have the whole input. Like, what do you do with that? Is it easy to do the to calculate features based on unbounded? Can I use windowed portion of data to do that? How do I do joins in streaming and things like that? So one thing in particular that I want to focus around in team collaboration here is that I keep saying it's team now. Before I didn't say that, right? So here we have the real-time computation and feature service, which are kind of similar but not really the same, because the part with the data warehouse, the feature service, prediction service, that was something that data scientists owned. And now the real-time computation is something else. So if you look at the stack that people usually use with that, so data scientist is someone who's really comfortable with their pandas, Spark, Dust, Python ecosystem. They're happy, and this is what they do. Whereas for real-time computation, immediately, as a real-time transportation Kafka comes, then we think about streaming processors like KeySQL or Flink, which is a whole another story because it's SQL, Java, Scala, JVM world. Oh my God, you like have to have separate people to take care of it. So that's why I'm saying team now, because it's like different, or multiple teams even. So, and I'm here with ByteWax, so this is a shameless plug. ByteWax is a stream, a stateful stream processing in Python. And part of the problem you can solve with ByteWax. So instead of using KSQL, Flink, PyFlink, or whatever, and dealing with the JVM ecosystem, you can use Bytewax instead, and that will give you a nice Python API, and you can still connect to your favorite real-time transportation Kafka or Red Panda or something else. And that takes some of the headache off, especially if you want to scale your Python developers. So if you have a group of people who are comfortable with Python, now they can do the real-time machine learning too, because they don't have to deal with the overload. And we have a blog on our website where we wrote about the idea of that and how we see that works. But that's, unfortunately, doesn't solve all problems. So, I wish it was, but we have to carry on with this presentation. So, and what if Bytewax is not an option? And I can imagine that easily. But what if, no, I cannot. Well, so what do you do with the model so that it works faster? What options are there? Because, of course, there is computation that happens, the prediction that happens with the model and something around. So you can sacrifice some of the input features and reduce levels in decision trees, reduce layers, make it not so deep learning, but still have an adequate answer to that. Or you can use the compression distillation. That's where you have a model, like a teacher model and a student model, and the student model tries to learn from a teacher model. So this is really hard, don't do it at home, but there are good articles on that, as well as quantization. So these are things really that when you do them, you have to keep in mind that this is trade-off between the speed of the answer and the quality of the answer. If you change your model, like it has to predict less. Yeah, but as a software engineer, we still have the part on that diagram that I have. We still have the part where something's happening before the model and something's happening after the model. So we could look at the at these parts. Yeah. So before, the model and the app existed in completely separate environments. Model could not be bothered by the real time of what's happening in real time. But then, when we added this real-time computation, now we have to talk to the model directly, right now. So the question is, where do I put my model? Like, the naive approach to that question is to put that in a service. So pack everything in the web server and just deploy. So it kind of reuses existing infrastructure, but again, the problem is that it's probably different languages. And then if you want to scale a model, if you understand that you need to run more models, you cannot, because it's the one thing, big monolith. And then you cannot, like some of the models, like large language models, they're very greedy, and you need a lot of resource to run it. And there are a lot of problems actually with large language models. They don't let you access to this whole thing through ChatGPT, exactly because they couldn't scale to the number of people that they use. And then hardware is not optimized if you use this whole big thing. So a more adequate approach is to do that as a separate service, sometimes called ML gateway. If it's thin wrapper around the model. So first thing is that it's dependable. Now, if the model fails, it does not fail the server. So you can still serve something to your user. You don't have to fail all. Then it's flexible. So again, you can use different technologies, different stacks, and just talk through the network to each other, scale them separately, add as many models you want, as many backends as you want. Of course, it adds latency, because it's like network, come on. And infrastructure complexity, because now you have to run all these things separately, monitor them, and make sure someone knows how to deal with all of that. So some of the performance optimizations that I, as a software engineer or decision maker, can do without actually knowing too much about data science would be whether to use GPU or not. So GPUs are expensive, but at the same time very effective. So this is one thing to think. Then if we talk about this is, by the way, we're talking about the single machine. We still can run multiple models on the same machine, so scale it there. We can cache, because as anything, models are, the queries, the requests to the model might not be necessarily spread evenly, so you have to give something that people often ask to real quick. And the caching is really deep topic, and we could have had an entire conference about that and wouldn't be done by the end of the week. But this is something really to think about. Then batching. Yes, we do want to do real time point by point, but sometimes it might be too expensive. So we can wait for a little bit, batch them, and then send them, parallelize them, and like give an adequate question still. And the last thing is that if your GPU is expensive, I said, and if you are not using the whole GPU thing on your machine, you can just run multiple things on there, multiple models, different models, doesn't matter. As long as you can, as long as you're careful about threats, you're good. So, and of course, we can look at the horizontal scaling and wrap your models into the containers and use something like Kubernetes and run them across the cluster, be happy, or use the serverless options, again, run them into, like, wrap them into Docker, have one single point, and make it somebody else's headache. Well, so my presentation today was more about the approaches that exist. And there are other wild things out there. So first is edge deployment. That's when you put your model right into the client. And I don't want to say nobody should do that, but that's the last option to consider. Still very interesting to read about these things that people are doing there. Then there is online training. What I was showing was all about online prediction. But the actual training of model, adding, like refreshing, is all offline. So right now, it's more like a research area for people to do the online training, but still there's progress there and interesting things to see. So, and since I'm here with ByteWax, I'm gonna repeat this stuff. Probably if you have a team of Python developers and who want to go real time with their machine learning pipelines, we'd be happy to talk to you. So, yeah, thank you for listening.